There is a planet in our solar system that looks from a distance almost beautiful, bright, white, perfectly wrapped in thick cloud cover that reflects sunlight back into space with a kind of eerie elegance. On a clear night, it is the brightest object in the sky after the sun and moon. Ancient civilizations called it the morning star, the evening star. They named it after the goddess of love and beauty. They had no idea what was underneath, because underneath those clouds is the closest thing to hell that actually exists in the physical universe. Not metaphorically, not poetically, physically, measurably, precisely documented by instruments we sent there, watched malfunction, and never heard from again. Venus is a disaster, not a passive, indifferent disaster like a dead rock in space, an active one. A planet that seems by every physical measurement we've taken almost specifically designed to destroy anything we send into it. And we know this because we tried, repeatedly, desperately, for decades. The story of how we learned what Venus actually is not a story of discovery. It's a story of machines dying one after another in the most hostile environment in the inner solar system, each one transmitting just long enough to tell us something terrible before going silent forever. Let's go there. Let's descend through those clouds. Let's find out exactly what killed them. You enter the Venusian atmosphere at roughly 100 kilometers above the surface. Up here, it's almost manageable. The temperature is close to Earth-like. The pressure is similar. If you didn't know what was below you, this layer of the atmosphere could almost feel like home. But you are falling. And as you fall, everything changes. At 60 kilometers, the clouds begin. Not water clouds, sulfuric acid clouds, dense layered bands of concentrated sulfuric acid droplets that wrap the entire planet in a permanent chemical shroud. These clouds are the reason Venus is so bright from space. They reflect 70% of the sunlight that hits them. Almost nothing gets through to the surface below, nothing except heat. Because while the clouds reflect incoming visible light, they trap outgoing infrared radiation with almost perfect efficiency. Venus has the most extreme greenhouse effect of any planet in the solar system. It has taken the same mechanism that keeps Earth warm enough for life and run it to its absolute logical extreme. Carbon dioxide atmosphere, 92 times Earth's atmospheric pressure at the surface, and a temperature that does not fluctuate between night and day, between poles and equator, between cloud cover and open sky. 465 degrees Celsius, everywhere, always. That is hotter than Mercury, the planet closest to the sun. Venus, which is twice as far from the sun as Mercury, is hotter, not slightly hotter, 20% hotter. Because Mercury has no atmosphere to trap heat, while Venus has an atmosphere that traps essentially all of it. Your descent probe is still falling, 40 kilometers, 30. The temperature is climbing, the pressure is climbing. The sulfuric acid clouds are thinning as you drop below their base layer, and for a moment, the view clears, and you can almost see the surface below through an orange haze that turns everything the color of a dying fire. 20 kilometers. The pressure is now several times Earth's at sea level. The temperature is high enough to melt lead. The atmosphere at this altitude is dense enough that it doesn't behave like air anymore. It behaves like a fluid. You are not descending through a sky. You are descending through something closer to an ocean. A superheated, high-pressure, chemically hostile ocean made of carbon dioxide with sulfuric acid rain that evaporates before it reaches the ground. 10 kilometers, you hit the surface. And here is where the Soviet Union enters the story, because humans did not just theorize about what the Venusian surface was like. We sent machines there, actual physical hardware built by actual engineers, launched across interplanetary space and dropped into that atmosphere. The Soviet Venera program was one of the most audacious engineering challenges in the history of space exploration, and it is almost completely unknown outside the community of people who study planetary science. Between 1970 and 1984, the Soviet Union successfully landed 10 spacecraft on the surface of Venus. 10. Each one designed and redesigned and reinforced based on what the previous ones had taught them about how Venus destroys things. Venera 4 was the first to enter the Venusian atmosphere in 1967. It transmitted data during descent, temperature, pressure, chemical composition, and then it stopped, not because it reached the surface, because the pressure crushed it before it got there. The engineers had built it to withstand a certain pressure based on what they thought Venus was. Venus was worse. They rebuilt, they reinforced. They sent Venera 5 and 6, same result. Crushed during descent, transmitting just long enough to confirm that whatever they built wasn't strong enough. Venera 7 was different. They built it to withstand pressure far beyond what their models predicted. And in 1970, it became the first spacecraft to successfully land on another planet and transmit data from the surface. It survived for 23 minutes. 23 minutes. That's it. That's how long their best engineering, their most reinforced hardware, lasted against Venus. And it barely transmitted. The probe landed and immediately began overheating. Its systems degraded rapidly under the combined assault of temperature and pressure. The signal was weak, intermittent, barely interpretable. Scientists spent months analyzing the recording before confirming it had actually survived touchdown at all. For most of those 23 minutes, they weren't even sure what they were receiving. But they kept going. Because that's what the program was, a systematic, iterative, almost stubborn insistence on getting closer to an answer even when Venus kept killing the instruments. Venera 9 and 10 in 1975 were the first to send back images from the surface. And those images are extraordinary. Not for how alien they look, but for how geologically immediate they feel. Rocky, angular, slabs of stone with sharp edges, barely weathered, scattered across a plain that extends to a curved horizon. The light is dim and orange. The sky, what little the cameras could capture, is a haze of sulfuric murk. And then those probes died too, within about an hour. Venera 13 in 1982 lasted the longest. 127 minutes on the surface, 2 hours and 7 minutes in an environment that kills spacecraft the way boiling water kills ice. It captured color images, it performed soil analysis, it recorded the ambient sound of the Venusian surface, a recording that exists and that you can listen to. Wind moving across volcanic rock on a planet 61 million kilometers away at closest approach, recorded by a machine that was quietly being cooked alive. And then it died. Every single Venera lander is still on the surface of Venus. We didn't retrieve them. We couldn't. They sit there, somewhere on the Venusian plains, slowly being dissolved by the atmosphere, being flattened by the pressure, being heated to the same temperature as everything else on that surface. They are becoming Venus. Slowly, over decades and centuries, the boundary between the spacecraft and the planet that killed them is dissolving. The machines we sent to explore Venus are being absorbed by it. But here is where Venus stops being a story about engineering and becomes something more disturbing. Venus and Earth are almost the same planet, same size, same mass, same density, same distance from the Sun in geological terms, both formed from the same protoplanetary disk, from the same raw materials at roughly the same time. If you had looked at the solar system 4.5 billion years ago, before the atmospheres had fully evolved, before the surfaces had differentiated, Venus and Earth would have looked like twins. They are not twins anymore. Something happened to Venus. We don't know exactly what. The leading theory is a runaway greenhouse effect. Venus receives slightly more solar radiation than Earth. Its oceans evaporated. The water vapor amplified the greenhouse warming, which evaporated more water, which amplified the warming more in a loop that had no exit. The oceans boiled. The hydrogen escaped to space. The carbon, which on Earth is locked safely inside rocks and ocean sediment through geological cycling, outgassed entirely into the atmosphere, and Venus became what it is. But here's the part that should make you pause. Earth has experienced periods of dramatic greenhouse warming in its own history. Not Venusian extremes, but shifts significant enough to reshape the planet. And the mechanism that saved Earth, the carbon cycle, the chemical weathering of rocks that pulls CO2 back out of the atmosphere, the plate tectonics that buries carbon in subducting ocean crust, is not a guarantee. It is a geological accident that happened to work out, a feedback loop that happened to close. Venus is what happens when it doesn't close. Venus is not a warning. A warning implies you can act on the information. Venus is something more unsettling than a warning. It is a demonstration. A physical, permanent, right next door demonstration of what a planet looks like when the feedback loops that keep it habitable stop working. It has been sitting there for billions of years, 41 million kilometers away at closest approach, visible to the naked eye, named after a goddess, hiding the most extreme surface conditions in the inner solar system inside clouds that make it look almost beautiful from a distance. We didn't understand what it was until we sent machines there and watched them die. And even now, with everything we know, Venus has more secrets. In 2020, researchers announced the detection of phosphine in Venus's cloud layer. Phosphine, a molecule that, on Earth, is almost exclusively produced by biological processes or industrial chemistry. In Venus's atmosphere, in the cloud layer where temperatures and pressures are closest to Earth-like conditions, the detection was controversial. The methodology was challenged. The signal was reanalyzed and disputed. The scientific community is still not settled on whether the detection was real, but the implication is almost too large to process calmly. If there is phosphine in Venus's clouds, and if phosphine requires a biological source, then there might be something alive in the upper atmosphere of Venus, not on the surface. Nothing lives on the surface, but floating, suspended in the acid cloud 60 kilometers up, where the temperature is room temperature and the pressure is survivable. Microbial life, if it exists, that has never touched the surface, that has lived its entire existence in the clouds of a world that would instantly destroy it if it fell. We don't know if it's real. We genuinely do not know. But we sent probes to Venus thinking it might be like Earth. We sent more when we discovered it wasn't. We watched them die one by one, each one lasting minutes or hours before Venus finished with them. We have images from the surface of a world that has been killing our machines for 50 years. We have recordings of wind on a planet that averages 465 degrees. We have soil samples analyzed by instruments that were overheating when they took them. And after all of that, after everything we've learned, Venus may still be surprising us. There is a mission called Da Vinci currently in development designed to send a probe through Venus's atmosphere, surviving as long as possible, gathering data all the way down to the surface. Another mission, Veritas, will map Venus's surface using radar from orbit with a resolution we've never achieved before. We are going back with better tools, with the knowledge of everything that killed the Venera landers, with the specific hard-won understanding of exactly how Venus destroys hardware and new hardware designed to last longer against it. We are going back to the planet that has killed everything we've sent there, not despite what we know, but because of it. Because Venus is not just a cautionary tale about planetary science or greenhouse gases or runaway feedback loops. Venus is the closest thing we have to a miracle, a reflection of what Earth could have been. A planet that started from the same ingredients, in the same neighborhood at the same time, and ended up as the most hostile surface in the inner solar system. It is 41 million kilometers away at its closest. That is nothing. A rounding error on cosmic scales. A distance light covers in under 3 minutes, and it is utterly, completely, irreversibly alien. The goddess of love and beauty, the brightest light in our night sky, is hiding a surface hot enough to melt lead, pressure strong enough to crush steel, acid clouds that eat metal, and wind that moves across volcanic rock at speeds your instruments record right up until the moment they stop working. And somewhere inside those clouds, in the one layer of that atmosphere where conditions briefly approach something livable, something might be drifting, alive, in the acid, above the fire, completely unaware that an entire civilization on the nearest planet spent decades sending machines to find it, watching them die, and still hasn't stopped looking. If life can survive in the clouds of Venus, then the universe is not waiting for perfect conditions to allow biology to happen. It is finding the cracks, the margins, the narrow bands of almost survivable between the fire and the void. And if Venus has cracks that life found, then every extreme environment we've ever written off as impossible just became a question we haven't answered yet. What else are we writing off? What else is alive in the margins of something we call dead?